So when you get there, just go ahead and place 2 structural columns. With 1 beam between them.
How do we fix where you cannot see them again?
What's going on? Oh, if you start out drawing, remember, draw it on the level above. And then once you get that, in the 3D view, go ahead and turn on all of the analytical information. All right. So then that's the basic geometry. We're going to add 2 more things to this. We're actually going to want to add a boundary condition. So we want to tell the base of these columns what they're doing. So that's considered a boundary condition. So go ahead and select boundary condition. And if you get this, did everyone get this? So you have to load a boundary condition. So this is another sort of Revit family that carries information. So the way we do that is we go to Insert, Load Family, and then I'll hold here. Does everyone have boundary conditions on that? Go ahead and select that. And you see we should have 4 options. I'm just going to go ahead and shift select all of those and say open. Did anyone not have boundary conditions?
If you don't have that, if you don't have the folder right, you got to go and take it off the Moodle page again. Some of these installs.
Some of that didn't. Okay.
Do you repeat what you said?
Yeah. So I'm going to go back. So from the beginning.
Where is the family?
It's going to be insert.
It's a Dropbox link right at the top. To US Imperial, I think is what it's called. Might be on contract.
So do they store that differently than normal place where Autodesk stores
No,
it?
he's got crap installs because they're done in the middle of the night before class started.
Last minute. So if you have it, it's insert, boundary conditions, and then there's 4 options. Just shift select and load those in. In view graphics, VG or VV?
Okay.
VV or VG? And then the center tab, analytical model. And then you want to make sure everything's checked to turn it on.
Okay, gotcha.
I cannot load the following files.
Just under regular model categories, you might check that on the top list.
Chris, that Imperial Board didn't have it. Probably so.
It loads it.
Where did we pull it from?
My VG was on there too. I put it on the 3D.
But it's got to let you know the general residential system default. We got like 4 different models.
Try loading it in there.
I did it with structure.
Alright, was everyone able to get those in there? Or on their way to getting them in there? Try to skip it without bubbles. So if you're editing the cannot load and it says something about structural framing, just skip that and see if we can sort of pick that up later. Alright, so for those that were able to sort of get that in there, you're going to want to go to the Analyze tab, and then when you do boundary conditions now,
We clicked on that little small arrow beside it, and it comes in off the side.
we'll need to add these in. So the next little bit before we apply them, on the very bottom, there's a flyout menu. So we're going to want to select that. And then we need to tell these families which boundary condition to go on. So on the far right here, you see these boundary condition settings. So fixed, we're going to use the fixed family. Pin to pinned, and we'll line all these up to the ones that they are representing. So user defined is variable.
How'd you get to the structure settings? Sorry, we missed that one spot.
Under boundary conditions,
Okay.
this flyout menu on the bottom.
Thank you.
Yep. So once that's done, you should be able to apply your boundary conditions. And what these are the conditions for the column in this case. So in this case, I see I applied a fixed state. I can update any of these for however they are. So when you're dealing with beams, cantilevers, things like that, you can assign these different boundary condition states. Question? All right. So for now, we're just going to do 2 columns, a beam, 2 boundary conditions, and then we'll just apply a dead load to this, and then we'll start taking this into Robot. So then if you remember from Friday, the load, so on this one, I'm going to do a hosted line load. And right now, I'm just going to leave this as dead load and then 1,000 kips downward. I'm just going to pick my beam. I just want to provide a load on that beam so that we can see how that comes into Robot. Even if you don't have the boundary conditions, we should be able to still get some information.
It won't.
It won't let you put the load on it. Go ahead and save this out. Sure. Under the Analyze tab, it's very left. Select it. You're going to want a hosted line load, and then select your beam.
Do you have to change the GIPs?
As long as it's negative, you can leave it whatever it's set at.
Okay.
So in the Z direction, as long as it's negative for now.
And then the footing pieces that you have?
That's the boundary condition, so we'll see what we get when you get in there. We'll come back to that. I'll have to Google that. So, all right, let's go ahead and push this into Robot now. So on the Analyze tab, all the way on the far right, you should have, everyone should have the Robot structural link. Go ahead and hit that. And then we want this Robot structural analysis link.
Yeah, that's
What's that?
Yeah. Mine doesn't show it.
Mine's grayed out.
Is Robot installed on those machines?
Do we have to open Robot also?
No, it should do it itself. Have the people that have that, have you restarted anything since it was installed?
well, I
Logged out.
Robot yesterday,
Okay.
so I don't know if the computer's been, rebooted. Probably not.
If we have 2015 by 2014 Revit, will that be a problem? Like that 2015 robot?
Yes. Do you guys, are you guys on 2015 Revit?
I'm on 2014.
Ah. 2014 is probably going to be, whoops. That's going to be the issue.
Can we at least open this Robot instead of trying to get to it?
And you guys don't have 2015 installed?
No, my Robot's 2014, and the Revit's 2014. They're different.
They are different.
I think 15 will run on the 14 model. How does ISO model looks like that?
All right. No.
I've got it here if you want to use this.
All right. So for those who have the 2015 installed, go ahead and do your structural link. And then go ahead and send model. You don't need to update anything at this point. You shouldn't need to update any of this. We just want to send this off to the first time. So those who have that, send that off. You'll get this export. So this will send it straight to, straight there. And it should open Robot. So this provides a link back and forth. It's a bidirectional link. So the idea is that you'll be able to send the information over to Robot. You'll be able to analyze it, update it, and then bring information back. So the idea would be you're working with a structural engineer or you're doing this yourself. You send that out to Robot, the structural engineer, or yourself can make updates and then bring that information back. So this gives you a nice little pop-up window, see if there's any issues. Right now there really shouldn't be. Link.
It's only 15 here.
So then now you should have something similar to this. So for the people who are in 2014 and don't have that link, let's try this. From this view here, this 3D view, so we're going to try a AutoCAD on this. So we'll try a couple different workflows. So if we see in Robot, it'll accept a DWG. Actually, this is a background, so that's not going to work. Yeah, that's not going to work. Gotta watch that button there.
I didn't even press it.
You're quitting.
I'm done.
You're ejected from the room.
All right, for those, I'm not seeing a quick way to be able to get that over between 2014 and that. Just watch along really quick, and then we'll either have to get 2015 Revit installed on there, so you guys have this link.
So Robot 2015 Robot. Like I've got 2014 Revit. Should I just go ahead and get 2015?
You're not. I don't think you're going to have this connection. I don't think this connection was available in 2014.
I don't have that on 2014 Revit, and I have both
Right.
So we'll need both.
2014 and 2020.
Will we need
2015 on each one.
2014 and 2020.
2015 for both?
2015 for both.
So you need 2015 Revit and
Right.
Robot.
So you guys are running 2014 Revit.
Yes.
Okay. Split it.
Sam, I'll get you there.
Thank you.
All right, let's try this. So for those who have the 2014, Chris just tried the DWG. So let's go ahead and just try it. See what we can get. So let's go ahead from Revit. Let's go ahead and export CAD formats and then DWG. Hey Chris, did you do anything special on the export?
Yeah.
Okay. So nothing special on this. Just go ahead and save that. I'm just going to put it on the desktop. And I'm going to go ahead and save this one.
did you do anything on the
Okay.
import?
So then for the import, this should work on 2014 also. Go ahead and you want to start building design. And from there you just want to go File, Import, DW.
I did it as open project.
You did it as open. And then you just open the CAD.
Open the UAV.
Ah, okay. Okay, so it looks like it recognizes the CAD, explode objects. I'm just going to follow all the settings on this for now, see where we end up.
Yeah, that's all it is.
I didn't get that.
When you export, make sure you export in 3D view.
I did.
Let's say apply. Okay. All right. So is everyone able to get some kind of something into Robot?
So even if we put 15 on, we'd still need a Revit 15.
Yeah. They work together with the link.
Yeah.
They're going to have to reinstall Revit on all these computers.
No.
That's awesome.
They're gonna do a new build in here anyway. They're gonna love it fast.
Yeah, there we go.
2016. Okay.
Yeah.
So for Robot, this, I guess we'll just go through the UI a little bit on this, since we're all sort of just getting into this. So what you're seeing here obviously is just the center line of everything. If you look down on the bottom left here, you can affect your view sort of in the center. There's section shapes, and it looks like in the AutoCAD version it doesn't come through. If you select your, this is just a background. So normally we see, I'm just going to say this looks like a background to me. It doesn't look like it's information that came over that we can use, honestly.
Yeah, I just tried to run.
Because we just have nodes and bars. Alright, we'll see if we can figure that out. I'm going to go back to the link.
That's fine. We'll figure out how to get it in.
Yeah.
What else is usually included in the information?
So if I go from this. So normally when we bring this over, push this over to Robot, it usually opens up. And then in here what we get is we get the sections that come through. Up in the top right, we have an understanding of what the levels are. So each level. It knows what beams are on it, the columns. Has all those sections. And then the other sort of part to this and how we navigate around, a lot of the navigating in structure is done here. So we can understand this from a geometric standpoint, properties, loads. We'll be doing a little bit of the steel design at this point. So if you have this and you select steel design and then again steel aluminum design, it'll flip over to the design screens on this. To be able to get back to that, you go back up to this menu and you can go back to the structural model and geometry. So you'll have the different concrete and you'll have the different steel, but in navigating, this is generally how we'll get around. We'll have results. When we start running results, I don't think we have anything at this point. So nothing's run. So back in the geometry, the other sort of important part that I'll point you to is the calculations in the very center. It looks like a calculator on the very top bar. So if I select that, you actually see it runs. It should run. And normally when we do updates, we'll have that. So now, in this sense, all the calculations are run on this really simple beam. And then if I were to go to results diagram, and I can look at my moment force, I can now see what my moment force is in that beam. Likewise, I can actually turn on deformations. So if I were to check deformations and say apply, I can see how much I'm deforming. We can change some of the output on this, sort of how it's viewed by parameters and labels. We can add labels so that we know all of these different forces that are going on. Diagrams. So I'm going to go ahead and turn all this stuff off. This is just a graphic sort of representation of that. And we have access to sort of all of this stuff. All right. So in this, here, the next thing I want to do is show sort of a really quick understanding of running an analysis on the columns. So in this, what I'm going to do is I am going to go to steel design and then steel aluminum design. And that flips us over to this view. And what we should see are two windows on the right-hand side. What we're going to do is we're going to create a group out of these columns. And then we're going to run the calculations on that group. So I'm going to say I want a new group. I'm just going to leave it number 1. The way we select the members in the list, I'm just going to highlight the number 1 in the member list. And then just Windows select over these. And you'll see how the information is input. So it's a 1 space 2. So if you were able to do that, and so also for an understanding of this, each one of these comes in with a number, and if you hover over it or select it, you can see it. Also on the bottom left hand, you can actually turn on the bar numbers. And you can see all of this stuff. The view is in the bottom left here. You can turn on node numbers, descriptions, support, like your actual support symbols, which is related back to that. sections. So in this, if I were to go back to the members in this, I want the group to be 1 and 2. And I'm just going to leave all the other settings for now, and I'm just going to say save. So now in the second part of the calculations, I'm just going to do a member verification. And I want to select options. And I'm going to say by weight. So I want to analyze this by weight. And you see we'll have some other options that we can come back in and run this analysis by.
So it's literally just how much steel you're using?
Right. So for the lightest amount of steel.
Right.
So if I come back to the calculations, I'm going to actually change this to code group design, and I'm going to say number 1. So I want to analyze this group. So if I were to make up different groups, I can analyze them sort of specifically. So once I have that set, I can actually say optimize, and then run calculations. So if you are like me, I didn't place any bracing in this, so it's already recognizing that. So it didn't run any lateral verification, but we do have results. This is just a warning message, so we do have results. And we see that it ran the analysis on this, and we can see sort of what it's giving us. When we update this, we'll be able to put multiple columns in here and kind of see which ones work and which ones don't. All right. So in this, I'm just going to say I'm going to accept their recommendation for this. If you remember, this is a 12. This was actually a 12 by 32, and it's suggesting a 6 by 9. W6 by 9. So I can say change all. And then that will actually change the section of this. So now in this, we see our section is considerably smaller. And if we were to go back to structural model and geometry, and make sure we have that selected, it should have changed this section. So this W68. When we had a 12 by 26 from Revit. So it optimized that and sort of rearranged that. So now the idea is within Revit, you can actually pull that information back in. So the second sort of roundabout information on this would be to say structural analysis and then the same link, but this time we want to update model. And if we update our options, we can, on this bottom transfer optional, we want to check reinforcement and we want to check steel. We can do a number of things on this. In Robot, we can actually do the diagonal bracing, sort of put that in there, and then that will bring a representation of that over. It doesn't necessarily bring the geometry over. It brings the analytical model over. So there's a little bit of back and forth in this. And there's also, within Robot, there's also detailing, so actually doing the connections, and then you can bring those connections back in. So I'm going to say OK, and then again I'm going to hit OK. And then it should, if everything works right, It should have updated. Yep. So if you select one of your columns, and the way to see it is to do the drop down under the top left and then select your structural columns. You see this switched over to a W68 8.5, when before the only thing we had in there was one of these two. So that's the sort of round trip, being able to sort of do that design. The same thing goes for beams and that information. All right. So let's go ahead and
in order to do one of the models we did on Friday, we need to go in with the boundary points on all the the fixed conditions on all the bottoms of all the models.
that, and without the link,
Yeah.
does anyone?
I was just trying to Google how they did it in 14.
Does anyone have anything up here called extensions in 2014? So so Autodesk is famous for this. They have a couple ways to sort of get there. And if I were to, so this is 2014 now. So if I were to do new template, does anyone have what's called extensions? Any of this? Do you guys have any of that? Okay. So if you can, so this is another sort of way to go about this. So if you can,
Download for student version of Revit extension.
yeah, if you can download Autodesk Extensions. 14. If you have 14, go with 14. Well, like I said, they have a couple different directions to get at this. So if you're running 14, you don't want to do 15, try the extensions. What it does is, within Revit, it goes through the API out to Robot, does the analysis, and then brings it directly back. So it's sort of like saying 6 one, a half dozen the other of a way to sort of get it out to Robot and back. So if you have that, I think as a student you should be able to do that. Download the extensions.
Is extensions going to apply to Ecotech and flow design and all the other applications that you have? Or is it just for structural?
No, this one's for structural. That one's a little bit separate. So what this one does is in 2014, it'll install this this extensions tab here. You'll have access to static analysis of beams, which is essentially what we did in that design, you'll have access to all of this. And we can probably go over that later, honestly. After the Autodesk people come, it might be nice to see I'm kind of curious as what they have for this. But we can definitely do that. So if you can't get 2015 in both versions, you could go this route. It's kind of getting the same thing. And this one does have a really nice structural generator based on massing. So you can essentially take your mass and say, figure out a structure for this. So that's kind of interesting. It's totally cheating. Let's try a really simple one. So if I were to say, I'm just going to model something in place. I don't know. Wait, automatic? Oops. All right, let's see how this works. Extensions, analysis, structure generator. So this needs a divided surface. That's what I thought. So it's not going to do that. Probably. I'm going to go ahead and just provide a divided surface on this one. Do some -4s. Let's try this now. So it's thinking. Might be bad thinking.
So it's just called Autodesk Extensions?
Yeah, Autodesk Extensions for 2014, if you're doing that.
You can just search it on the, like in the search bar on the Autodesk site, put it on the regular list.
I think, yeah, you can get to it. I think you can get to it through subscriptions. You can get to it through Autodesk Exchange, I think, through Google's usually best. I don't think this is going to work.
I think we found a link to get the structural analysis to work.
Oh, nice. In 2014?
Yeah, for 2014, yeah.
How was that?
If you go on Google and like press to recording to
Mastermind.
Autodesk doesn't have it.
And then
I think it's in the extensions.
Is it part of the extension? Is it part of the
all right, cool. So honestly, I'm not sure it's part of the extensions because I have extensions installed on 2014 and I don't have that link either. But it appears as though, so like always, Google everything 2014 Revit to Robot. You get this, which sends you to install this, and it's free. So what this looks like it does is it provides you the same link, that bidirectional link between 2014 Revit and Robot. When you install 2015, I guess all of that just installs normally. I wasn't sure about that with 2014. So that should allow you to do the link back and forth, which I think is one of the better ones that Autodesk does because of how it actually works back and forth. So once you get that done, you'll be able to get that going. All right. So I'm just going to go ahead and clean this out. So I'm going to go ahead and update this a little bit, do some other, I'm going to add and subtract some things. So I'm going to go ahead and select this. And another pair. I'm going to add some bracing on this one. So structure, brace. Sometimes when you're adding sort of structural elements, you get the opportunity to do 3D snapping. Go ahead and select 3D snapping. And then connect your braces through. So in this sense, we have really oversized bracing. Going to connect this up. One thing in dealing inside Revit with the connections and beams, if you select a beam, and you see here under start connection, end connection, we can actually start to select the kind of connection it is. So in this one, it's moment frame at both ends. The nice thing about this is it can be either direction. You can do this in Robot, you can do this in Revit. I actually like to do all this in Revit. Go ahead and call that moment frame. I'm going to go ahead and apply again some more hosted line loads around this. In this case, I'm going to actually add, actually I'll just leave that for this last one. Go ahead and say structural link and update model. And in this one, again, we shouldn't need to update any of that. And did not get any new geometry. All right. Update. Yeah. Awesome.
If you didn't change the original, could you not just like resend a new model rather than?
You can. I mean, it's easy to resend a new model.
Yeah, so it looks like it works just like you did in 15 once you get that structural analysis 2014 installed.
Right. So I'm going to dump that structure. I'm going to send another one.
Did you install it?
I was just getting the 2014 robot off of Autodesk. I'm not sure if it's the same.
So now we see we get this model in here. Now we have bracing on it. And like before, we can go ahead and do steel design, steel aluminum. In this case, I'm going to go ahead and I'm going to say I want a new group. And I'm actually going to select everything. Oops. In this, you have to highlight it first before you select it. So in this case, it says 1, 2, 13. So it's going to run the analysis on everything. Remember to save your group. And run the analysis on this one's group 13. Again, like last time, I'm going to optimize for weight, but this time I'm also going to select minimum flange width and minimum web thickness. Say OK. Make sure you have a code group in there. Code group list. Come on. Yeah.
I did include Jason that's groups now.
And this one?
Right about now. No, I think you're in the numbers now in the definition.
Oh. Ha. Yeah, wrong one. Code group 15, optimize for weight. 1. Mine's messed up because I created all these new members. So delete, delete, delete. Group 1 to 12. Code group. All right. So when I run that on the whole part of that structure, it goes through and it gives me suggestions for what I should change this to. Now all this is going to depend on the load you end up applying to it. So if you've got a floor, or if you're just analyzing a portion of it to understand a module, say you had like a digrid module or something, or you had other module, you'd be able to analyze that to see how that one functions. So once this runs, if you're okay sort of accepting these, again, you can say change all, and then sort of push that back in. So this is the, I'm glad we got the 2014 thing kind of figured out. This is the sort of last part of that. Anyone has any questions? Shoot.
So if you put, just say like a composite deck floor with the steel and the poured concrete, is that going to automatically associate a dead load, or are you going to have to go through and designate the dead load?
You're going to have to, when you're doing this in Revit, you would have to go through and designate all those loads. So in Revit, you can go ahead and if you look at the load types here, we've got, you end up doing your dead load, your live load. You can apply wind loads to this, any other snow loads, and then sort of any sort of temporary loads. So like for instance, on that slab, if you had a large piece of equipment, you could do a point load at that point for whatever that is. And then once that pulls through, sort of all of that is figured into the sort of analysis on the robot side.
But it does calculate the weight of the member itself, right?
I think so.
So if you
In this, when
put
you're
put a floor
optimizing.
on top of that frame, it would account for the weight of that floor system, rather than you having to calculate the weight of it and count it to dead load.
Yeah, it should. If you're,
Right.
I believe that if you're, the code's coming in as a load, right? But the dead load is a separate load than the actual weight of the concrete and the composite deck, right? So if you're using the definition from Revit, that is the, 3 inches of concrete on a 2-inch, whatever for your 5-inch, right? All of that mass information should be built into the definition. But if you create your own floor, you need to make sure you have the mass information in there in order for it to have that information, right? Or, like, most likely what you want to do is duplicate that composite deck. Create your own from there, and that'll have the base information. It should carry that weight into.
It should. In the import or the link options under send model, send options, if you, and again, there's like tons of tutorials on this. If you see sometimes they select ignore self weight. I'm not quite sure why you would want to do that, but that's an option there. In inferring that they have that option, it takes in that weight. And yeah, it's the Revit floor. So if you have a generic 12-inch floor that doesn't have that in there,
It doesn't have the mass properties you're gonna.
right. So if you were so the thing to look out for on that, so for, in this case, I'm going to be doing a structural floor. And then I do that, and then if I look at the properties of the floor, so I did a generic floor 12. So what I want to check for in this is that it has analytical properties. So in this sense, I can, if I turn off all the geometry, I have this analytical floor. Even though it's a generic 12-inch, I see I still have areas and perimeters. It has an analytical counterpart to that geometry that it's pushing in there. So it looks like, even if it is generic, it's taking that information in, but it might not be the right information you want.
It looked like the only thing it had associated with it was that it was a one-way slab.
Right.
But maybe not even the weight.
Right.
Self-weight.
But that's something definitely to be looking out for. And I will say the one other thing to remember is that it's checked for structural. So that's so in this sense you can make a roof, wall, any of that stuff, you can turn that structure on. It's got volume, thickness. Sometimes where this comes through is in the materials.
Right.
And it comes through in the physical materials. So in this, all this is set up. So if you have, even though this is this, oh, I switched this over to metal deck on concrete. So the material, the lightweight concrete, has all of the physical attributes going with it. So that's where it should be pulling the information from. And conversely, it does all the thermal stuff too for other.
So does the generic 12-inch have that? I guess if it's defined as concrete, it would have that 110 pounds per cubic foot. Yeah, if you do it as regular concrete, it goes up to 150.
Right.
This casting plate, the lightweight goes to 150.
So right now it's generic. So you could do an analysis of a generic floor assembly, and then say this is, a generic 12, and then apply a material to it. Say this is all lightweight concrete, and then you do generic 12 with, regular weight concrete. Those are going to have two different parts, but you can do it as a generic sort of chunk. So you might not necessarily need to go down to a real finite level. So that's another way where you could do sort of iterative design based on that, and see how that affects the member sizing in robot.
Does that make sense to everyone? So you could set up your own generic floors and then assign change the material properties so that it has a different loading characteristic, so you can understand what different assemblies might be, right? So you might be able to estimate what the 5-inch concrete with a raised floor system with carpet or with tile, and sort of get an idea about how much that weighs and throw it in there. As a generic slab, just changing that number from 110 pounds per cubic foot, just I would guess that might be something closer to, I don't know, with all the air in the raised floor, it might be something like 40 pounds per cubic foot.
If you end up going down that route, you would have to create your own material for that assembly. So, like if you had the raised floor, that would be like one material that you apply to the generic. And then if you had sort of really based like polished concrete with would be another material. So it really goes down to the material part of it.
The other way to do it would be to put your composite deck on there and then create two dead loads, one dead load being your material assemblies, like your carpet or your tile or whatever, and then the other dead load being the design dead load, right? So depending on what, typically that's driven by program. Every program will have a different design dead load that you have to accommodate for, and then a different live load, right? So a library has a different dead load characteristic or a different dead load profile than, you guys probably already know this, right?
Yes.
Than an office building. And that's all driven by code. But this other dead load that I'm talking about is more the actual weight of the building products, the assembly that you're going to be putting into the building, which wouldn't be accounted for in those design dead loads. Right.
Right. Any more questions?
Can you run through the 2014 plugin?
The installation of it or the use?
You use?
It should be the same. So when you have...
So I have a couple things that look different. Yeah.
So you did have this link?
Well, you can see it here. I have under analyze, I have these things now.
And there should be another drop down in there too. If you just have to Did you try it? Yeah, so once you select it, you should have the exact same thing. So, so there's a couple other options in 2014. Awesome. So the extensions are almost the same thing, it's just in Revit. Cool. Yeah. All right. So the next step would be to bring in the 5 floors, or if you want to start with 1 floor, sort of analyze that. The idea would be to set up that group of, you want to grab the columns, the central wall is going to be a little bit different, and then run the sort of analysis on that and see what you're getting. Right now we're just looking sort of at that either live load or dead load. Obviously, it gets more complicated with factoring in wind loads and all that. So yeah, if there's no more questions, I guess.
Thanks, Jason.
Cool.
I'll go back through this too once more and can help sort of reinforce it in top crack. I put a better